Good morning, students. This is the second class of chapter 3, Energy. And already we have seen a brief introduction of this chapter, or we can say this unit 3.1, which is based on the topics energy and work and the units. So we have seen that how all living beings perform the certain basic activities in order to survive, and for performing these activities they need energy, and we have seen the definition of energy also in brief. Okay, so in this class we'll start unit 3.1 and we'll see the concept of energy, the concept of work, the factors which determine the work, and the units of work and energy. Okay, so first we will see the energy and how it is related with the work. Clear? So as we know that the word energy is commonly used in our daily life. Science has given it a definite and precise meaning, and which is the capacity or ability of a body to do work is called energy. Clear? That means in a way the total amount of work done by a body is numerically equal to its energy. Clear? So this ability to do work may be either due to the motion of the body or its higher position above the ground level. Clear? But now the question is that how it is related with the work. If the energy is the capacity or ability of a body to do work, then what is work? Clear? So work can be defined as the transfer of energy. Clear? So they both are directly proportional to each other, or we can say that the work and energy has the direct connection. In that way, work and energy are related and they both have the same SI unit also, and it is joule. Clear? That means the capacity or ability of a body to do work is called energy, and the work is defined as the transfer of energy. Clear? So they both are directly proportional to each other. Clear? So this is the energy, which is the capacity or ability to do work. But in physics, there is a different definition of the work. Clear? So now we will see what is exactly the definition of work. In everyday language, any physical or mental activity may be regarded as work. For example, a teacher taking a class while standing is doing work, or students learning while sitting on the benches are also doing work. However, all such activities do not fall under the heading of the work. In physics, work is said to be done only when the applied force causes some displacement of the body in its own direction. Clear? Suppose when you are reading, writing or singing, we may say that we are doing mental work. Similarly, if a teacher is taking a class while standing, he or she is doing mental work. But when a girl is cycling, she is doing physical work. Or when a laborer carries some bricks on his head, he is also doing physical work. When a car, bus or train moves, it does the mechanical work. Okay. So, in the case of pushing a wall, there is no work done. You can see here, the man is pushing the wall, but he is exerting the force, but there is no displacement caused. Okay. But in case of pushing a table and it gets displayed in the direction of the force, then we can say that work is done. because force is that man is exerting the force and it causes the displacement. So when we can say that the work is done, the work is said to be done only when the applied force causes some displacement of a body in its own direction. In its own direction, that means in the direction, in that direction in which the force is exerted. Clear? You can see here in both the animated pictures. So in physics, there is a different, definition of the work. When a force causes displacement in its own direction, work is said to be done. Clear? As we have seen that when a force causes displacement in its own direction, work is said to be done. That means force or we can say work depends on some factors. So now we will see the factors which determines the work. Okay. Consider a trolley being pushed from position A to position B through a distance x. You can see in the diagram. Some force is required to move this trolley through distance x and hence some work is done because displacement is there. Now the second case, imagine that the trolley is filled with luggage and it is again moved from A to B through a distance x. So it will be obvious that the force required to do so will be more than that in the first case because now the luggage is there in the trolley. So in other words, more work is done in the latter case. So we can say that the work done by a body depends upon the force applied. That is, the more the work done, the more is the force applied. That means the work done by a body depends upon the force applied. That is, the more work done, the more is the force. The first factor on which the work depends is the force. Clear? Now consider a trolley filled with luggage and let the trolley be displaced by 2 meters from A to B by some force. And some work is done in moving the trolley. You can see in the diagram. If the same force is used to push the trolley so that displacement is 4 meters, the work done will be double. Thus, we can conclude that more the displacement of a body, more is the work done. So, we can say that the work done by a body depends upon the displacement of the body. More is the displacement of a body, more is the work done. So, the second factor on which work depends is the displacement. Clear? So, mathematically, work is defined as the product of the force and the displacement through which force acts. Or in short, we can say that the formula of work done, W is equal to F into S, where W is the work, F is the force and S is the displacement. Clear? So this will be the formula. Okay. Now we have to see that if no force is applied, what will happen and how these factors affects the work. Suppose if no force applied, that means in that case F will be 0, and by putting the value of the force in the formula of work, we can see here W will be 0 into S. So in that case W, or we can say the work, will be 0. That means if the force up, or we can say the applied force, is 0, the work will be 0. Clear? Or in the second case, if there is no displacement, we are exerting the force on the object, but that object is not displacing. Okay, so in that case displacement S is equal to 0. So by putting the value of the S in the given formula of work, W is equal to F into 0. So in that case, work will be 0. Clear? So we can see that if there is no displacement, work is not done. So in that way, we can see that work done by exerting the force which causes the displacement in its own direction. So we can see that in that way, these factors determines the work. Clear? And these factors are force and the displacement. Already we have seen about the energy and the work and how they are related with each other and the factors which determines the work. Now we will see the units of work and energy. We have said that work and energy has the direct connection or they are directly proportional. So in that way, the SI unit of the work and energy will be same because energy is a kind of work and work is a we can say that the transferring of energy. Clear? So in SI system, the unit of work is joule. And what is exactly the joule? When a force of 1 Newton causes a displacement of 1 meter in its own direction, the work done is said to be 1 joule. You can see here. That means J is for joule, N is for Newton, which is the SI unit of force. M is denoted for meter, which is the SI unit for displacement, or we can say that distance. So in that way we can say that 1 joule is equal to 1 Newton into 1 meter. Clear? Now we will see the unit of energy. As I told you, the unit of energy energy and work are same, but here we have to see that the old unit of energy also. So calorie is an old unit of energy. So what is exactly the calorie? Okay. So the amount of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius is called 1 calorie. This is the definition of this unit, which is the calorie, and calorie is an old unit of energy. Clear? But however, it is small for measurement, so bigger unit was required, and that unit is called the kilocalorie. Now the question is that what is the kilocalorie? So the amount of heat energy required to raise the temperature of 1 kilogram, or we can say that 1000 gram of water through 1 degree Celsius is called 1 kilocalorie. And the conversion is given here. 1 kilocalorie is equal to 1000 calories. Clear? Or we can change it into joule also. Clear? So this is all about the units of work and energy. In the next class, we will see some numericals which are based on the work and the energy. Clear? So that's all for today's class. Thank you and have a nice day.